Welcome everybody. Back to our live stream. Sorry about being late one day. We had some other fixtures on Saturday, so I had to do this one on Sunday instead. Anyway, in case you're watching the recording, don't really care about that. So I'm still Johannes. I'm an instructor for deepdives-eu, and I specialize in developing and machine learning, data analytics. And with me, I've got Mikko, a very good friend, another instructor from the same company, who maybe is a little bit more development oriented than me, at least currently. All right, I guess so. And our topic for today is microservices. And this is something that a lot of our students don't really maybe understand all the way. And but we wanted to, or I wanted to show that even though everybody is talking about microservices, we should consider whether it is the best possible architecture depending on our actual project. And as my devil's advocate, I've got Mikko, right? So you're going to throw out all of the obstacles that you can see, and
it will be my pleasure.
Yeah. So
before you start, you mentioned that our students maybe don't know so much about microservices, but if we have people on our courses who have similar background as we do, meaning long background with development, software development, they are also against. They are specifically against microservices, and hopefully our presentation here maybe changes a little bit. About
that. It's that both kind of extreme opinions are wrong, right?
Yeah.
It's more about and this is interesting, this kind of positioning talk first. Right? We're going to be talking about microservices in a second, but just kind of to make sure the motivation for this kind of comes from exactly that a lot of our students, that's what our experience basically comes from, either think that microservices is the best thing since sliced bread, and everything needs to be microservices, or they're the opposite opinion. This could be just change resistance. So we've always done things in one way, and we will continue like that forever. And both of these opinions are based on not knowing enough about microservices. That's kind of my point here. So I'm hoping that during our discussion, people will both be able to see the pros, the benefits that come from using a microservices architecture, as well as the cons. So the problems that will arise from using microservices architecture, and then maybe they can place it better. Kind of, they can see that there are certain circumstances where the benefits way overpower any kind of problems that come from the architecture. And then, of course, we should think about the architecture as an option. So that's kind of the motivation here. So for me, it's not about being pro or con microservices, but rather understanding what are the parameters that make it an interesting option. So what are microservices? So we kind of talked about microservices in our DevOps show not too long ago, and microservices is presented in the DevOps context as one of the best practices to use, to get more DevOps maturity, I guess, is the measurement that we're doing here. But like we discussed, it's not really that much of a black and white decision. There are many things to consider. And in general, what we mean by microservices is that instead of having a single program that is running your application, like, I don't know, Google Chrome could be the browser that you're using to watch the show. That's a single binary. It's called a monolith. So instead of having that, we actually have multiple smaller services that then talk to each other. And there are a couple of things that are beneficial, especially from an organization point of view, from this. But a lot of time, like I said, people don't really understand the added requirements that come from running this kind of an environment. So I could say as a couple of examples. On one hand, we have monolithic applications like your browser or, I don't know, Microsoft Word or stuff like that. They still have components within the application, but they're generally talking to each other locally, and they have got hard dependencies on each other, dependencies that are hard written into the code. And the microservices, on the other hand, are these individual parts of your application that are totally isolated and independent. So any kind of dependencies between them go via an API, and then we can control changes in those APIs using versioning or whatever else. And this has a fairly big impact on how software gets developed. Like, let's talk about the runtime separately. Let's just talk about the organizational view first. Because if you are running a large monolithic application, one of the dangers in that is that there might not be anybody in your organization who knows the full code base, just because it's so huge. It's like it could be humanly impossible. And there might be these kinds of situations where you have a part of the code that is, singled out to a single person. Something that was so difficult that only John on the third floor knows how to touch that code. So don't go there. And this becomes a risk over time.
And it really is like that.
Yeah.
Sometimes when you have large systems, then there are just a couple of people who actually can, fix a problem or refactor or really understand what's going on. And that is a problem.
It could be like legacy code.
It could be even new code.
Integration to a system that it doesn't get used as much, and then it literally people don't know how it works, right? So the older the project is, or the older the code is, the more likely it is that it has these kind of dark passages. You shouldn't go alone to that. So let's just take this part and contrast that to microservices. So with microservices, in the ideal organization, we would have these fairly small teams that would work on that microservice themselves. Different organizations have different strategies. Amazon has brought the two-pizza team language into the team size. But basically, you have a small group of people that can run and develop a microservice. And now the cool thing, just from this perspective, is that now the code is small enough that basically everybody in that team can work on any part of that code. It's small enough for our small brains to be able to actually comprehend the whole project in one, and all of the dependencies and how it works and what to do when. So that basically raises the quality of the software automatically, which is kind of interesting, right? That makes life a lot easier. Now, of course, in smaller organizations, it's difficult to go with this two-pizza team ideology, because microservices, there might be more microservices than people in the organization. So that doesn't work perfectly. But in very large organizations, like Netflix or Amazon, something like this works in a great way.
But still, you would be you could use microservices even if you have just a small number of people there.
Yeah, you just don't get all of the benefits. Like one of the benefit in a small team is just communication. So again, let's use extremes here. So on the one hand, let's think that you have like, I don't know, 200 developers working on a product. Whenever a developer needs to make a breaking change in the code, they need to let everybody know that the way that our code is working is going to change in the next version. So like probably as a developer, you need to kind of get a manager that will then, I don't know, write a memo and then email that to everybody. And then everybody needs to read that memo to be able to get up to speed with the changes that are happening. And then there could be like one department or one team there that says, we can't do that. We don't have enough time to refactor our code to take into account your changes. So your changes are then going to have to be moved to the next release and so on. So communication in a large software project with a lot of developers needs to have a certain amount of formality to it. There needs to be this kind of written communication, and that takes time. Takes time away from development, from velocity.
But before you continue, I just have to say that that's not necessarily a bad thing, because sometimes
that's the way you do it.
First of all, you might have to do it, but sometimes you might have to have auditability or traceability, what has been decided and who made those decisions, and that sometimes in certain fields that's a must.
Yeah, absolutely. But then to go to the opposite way, to the microservices environment, we have maybe 5, maybe 7 people. Ideally, pre-COVID, they would be sitting very close to each other, so they could just shout that, hey, I'm going to change, I don't know, the logging file format to be different from before. And everybody hears that, and they're like, okay, do that, right?
And the benefit and why that actually works is that since it's a microservice, it should be, from the outsider point of view, it's a black box.
Yeah. No hard dependencies, right?
Yeah,
so you
no hard dependencies. So it's up to you how to implement whatever you need to do.
Yeah. The cool thing here is that you can actually get something like this, where you actually want to have feedback from your peer developers. You can do that in a matter of seconds, instead of having to write an email, send it to everybody, and then wait for responses that never come, and blah, blah, blah. Nowadays, I guess we use something like Slack to kind of simulate this. So we can just throw our ideas into a Slack channel and then get immediate feedback, and then do things. And then it's also asynchronous. So if someone is away, they can go back to Slack and then see the discussion that has happened. So there is this kind of documentation happening. And then, of course, finally, the documentation will happen via the commit notes when you push the change over into a version control system. So it's not like they're not.
If you do that.
Yeah, you need to do that.
Of course, I do that always. I have good comments there, because that's
I have multiple commit messages that are exactly the same. But yeah,
never.
But yeah, so kind of, we still have communication, and there is a formality in it. Like, for example, in the commit notes. However, it is no longer as formal, and it's not breaking the velocity of the project. Right? So things just happen a lot faster. And this then also makes it possible for us to use this best practice from DevOps, where we make lots of small changes instead of huge changes every now and then, right? Because we don't have to wait for people to approve our changes. We can just do them. So then we just do them and push them into production and see how things work.
Actually, now that you mentioned that, with monolithic applications, you can and you should be making small changes, especially if you have a larger team working on the same product or software, whatever that is. Small changes, usually you break less things if you make small controlled changes. Let's say this piece of software is already in production and it's working already, then you make changes.
It's just much more difficult.
But the challenge is when to push the changes into production. And with microservices, you make small changes and you push them into production.
Exactly.
And that
gives us
the
velocity.
difference there, or one of the differences.
Yeah, so it kind of depends. In a large project, you can try to do small changes and push into production, but then you get into branch management. So you need to kind of choose which changes to push at what time, because the branches might be conflicting. So,
and my personal opinion is that you should not play with the branches. It gets so complicated, and it just complicates things even further.
Yeah, but if you want to do lots of small changes in a large project, then you have to use branches. There's no.
Or you have a strict release cycle, and you stick with that. That's a possibility as well. I've seen that, and it works.
Yeah,
of course, not always, but there are so many different ways of achieving good end results. But let's stick with microservices. What else? So,
okay,
small changes.
So this was like from the development organization point of view, right? So there are these benefits in having just a smaller code base, right? Now this, of course, also goes through the CI/CD pipeline, because, for example, testing a smaller code base is simpler than testing a larger code base. So when moving towards microservices, you at least should be able to create better test coverage, because creating the tests themselves is going to be easier, and managing all of that is going to be easier.
At least it's manageable, but still, if you have a monolithic application which is properly built, then the amount of testing, let's say amount of functions that you have there, it's about the same.
Yeah.
But it's so much easier if you have one simple project and you need to have like a full range of tests. Yeah. It's easier, like mentally, it's easier to manage.
Exactly. And
but you
there should be a little bit more motivation to do them, because in large projects, coverage doesn't get very high because it's demotivating to actually.
For some people, at least. And if you start the testing as an afterthought, then it's like a never-ending story.
Exactly.
Hundreds of thousands of lines which have not been tested in any way, and it gets really, then it gets demotivation a lot.
Yeah. So there are benefits, and then also kind of from the technical point of view, so there are less dependencies, right? Because if the whole application has all of the dependencies of all of the different parts, then a microservice would only have a subset of all of those dependencies. So we get a little bit away from the complexities of dependency management, needing to ensure that we have a local copy of the dependencies available, so that our build is not dependent on whether the internet site of that dependency manager is actually running, and that kind of stuff. And then also the actual binary or the artifact that we're creating is going to be smaller, right? So there's kind of less things that can go wrong. It's going to be downloaded quicker. The building process is going to be quicker than with the large application, and that could also have an effect on the velocity. So I have an extreme anecdote here. I don't know if you've read the autobiography of Risto Siilasmaa.
I've heard of it.
So
I know what you're going to say. Yeah, I know.
Yeah, he was the founder of F-Secure, or whatever it is called now, and then he was actually in Nokia after Jorma Ollila, when things started to go wrong. And in that autobiography, he actually says that one of the reasons why Nokia kind of lost the game to basically Apple in the mobile world was due to the fact that their CI pipeline for the Symbian OS, the Symbian S60 OS, was too long. And he said in his autobiography, it took like a week for the operating system to be rebuilt and then can be tested. And then that, of course, that's free. Right?
That's like
of course,
incredibly slow.
Yeah, and it was just due to the fact that it was actually built as an monolith, so there were kind of no stage separation. And it just kind of grew into that, right? It was kind of a legacy project that just kind of happened to go that way. And as more and more stuff was added to it, the build time just exploded. But yeah, it's kind of an extreme example where you see that the longer the build time is, the longer your developers are working, not in a very productive way, because they need to get whether or not their changes have been okay or not, and then work.
I can easily see that's like impossible situation, because in real world, when you're making changes, sometimes you need to have the whole product ready to see if it actually works. Even though how well you make the changes and how no matter how professional you are, sometimes you have to just try if this works or not. Like in real life, you just have to try. And if it takes a week to see if it works, it makes absolutely no sense.
But
you
okay,
always waste a week.
Yeah, to be honest, it was the operating system that is working directly on the hardware, which is custom hardware by Nokia. So it's kind of understandable that they actually have to do this. They can't just run it on a simulator and then be happy with the outcome of that. But yeah, that was kind of in his words. Sorry if I'm misrepresenting something, but that's how I understood when I listened to the autobiography. And it's a, in my opinion, it's a good example to kind of show how extreme things can be, and what a disastrous effect. Everybody understands that. If you're
okay, let's go to the other end. Show or tell us how quickly a change, when a developer receives a bug report working on a microservice architecture. A developer receives a bug report. This person knows that, okay, this is an easy fix. I'll fix it. When is this going to be in production? Not in a week, but
so this is actually in the state of DevOps report. They gather this information from different organizations, and if you are in a mature DevOps level, which is companies like Netflix and Amazon, then it is less than 1 hour for the fix to be, including like developing the fix, if it's a simple fix. So this is, and that is the velocity that we're talking about here. So that there is no kind of infrastructure reason why, once you have created a change, it can't be applied into the production environment as quickly as possible.
That's really impressive.
Of
course, if the fix is easy, sometimes it takes more than an hour just to figure out where to touch and where to look. But once you get your hands on the keyboard and start to fix it.
Yeah. But these are numbers that are published. The reports are available on Google. I think we talked about it during the DevOps issue as well. But yeah, it's really cool. And if you think about like a website like Netflix, or a service like Netflix or eBay or Amazon, these kind of behemoths of services. And basically, whenever you're refreshing your browser, you know, some microservice that's in the backend or somewhere has been deployed between your refreshes. So you're kind of you're seeing a different version of the website or the app every single time that you interact. And that's kind of interesting. And that also shows us one of the problems with microservices. Because now, if there is a bug, that is not necessarily localized in a single microservice, right? So it's not like a programming error that with some input gives you the wrong output that you didn't anticipate. But rather, if the bug comes from interactions between microservices, it's really difficult to find the root cause for that bug, right? So it's not only about visibility. That's one part. So visibility is problematic because we need to figure out what has happened across multiple microservices, each of which would do their own logging, right? So we need to have some kind of a system in place that gives us traceability. So there might be like a unique ID that gets injected into all of the requests, and then that gets forwarded, and then everybody logs that so that we can try to figure out what happens in the back. But that alone is not enough, because some of the microservices that were part of that chain might have been redeployed in between the bug manifesting itself and you starting to try to fix it. So you need to
one of the really frustrating situations when somebody reports a bug and you just cannot reproduce it in your test or development environment, or even in production in this case, if it's something that you can try to,
Yeah, so you need to kind of check the timestamp of the request, and then hopefully somewhere you have all of the deployments, so you can figure out later on which version of each microservice was running when the bug actually happened. And then what you could do is you could deploy those versions on like a different versioned API and to try to replay the bug. But it's hugely complex compared to kind of traditional debugging.
And there's one more thing, that even if you get the right versions and you have the right input and everything is exactly the same, you have copied the production database into test environment or development environment. But since it's a distributed system, highly distributed system, then it's some sort of race condition that due to a hiccup in a hard drive somewhere in the background, something happened slightly slower than it should have happened, and you maybe are it could be that it's impossible to reproduce the problem.
Yeah, like just
and it's slightly easier with monolithic applications. Because you don't have that kind of problems. You do have race conditions with monolithic applications as well within the application, of course, but it's slightly less complex.
Yeah, and then this could be something random that is not, you're not able to even redo. It could be something like just some packets arrived in a different order, so it took the TCP stack longer to get that data read, and then maybe, I don't know, maybe the stack used up all of its memory and then needs to say to the sender that please resend the future packets, and then there's a hiccup. You never know, right? Things happen. So the way that we create microservices is that we always try to fail gracefully locally, right? We need to understand that failure is going to happen. Whereas in a local, in a monolith, when you're calling functions, you're not really preparing for the function not to be callable, right? It's like you're presuming it is there because your code gets compiled. So any kind of names get checked.
You might check what the return value is. Is it valid return value, but it's not going to fail because you call that function.
Exactly. Yeah. Whereas in a distributed system, you need to be aware that the network might not be reachable, either egress or ingress on the other side.
So that makes things more complex.
Yeah.
Not only from like a system point of view because it's distributed, but from the application, like a software architecture point of view, because you have to do more and different kind of error handling within your application.
Good example here is the circuit breaker, very well known pattern. I think it was by circuit breaker. I think it was by Netflix originally.
If you zoom in a little bit, yeah, thank you.
Yeah, we have no. This is just code. Well, why not? But yeah, so the idea. Let's see if we have a better like an image. There we go. That's good.
And then it's fun to figure out if the problem if the problem that you had, is it something that you just accept that, okay, this might happen once in a million messages, and then you're actually not going to do anything about it.
Yeah, that's
Because if you try to take into account every single thing that could ever happen, you're never going to finish your application.
yeah. You kind of need to know
When to stop.
what to do.
If you don't find the circuit breaker, then
oh man, yeah. Well, the idea is, I think this is the best version that we have here on the right-hand side. Sorry about that. So the idea is that it's basically a facade. Well, no, it's on the client side, but still. So as part of your software, when you're calling something from a different microservice, you do that basically via a local proxy, right? So you give the control of the actual communication to somebody else. And that proxy tries to connect to the microservice, and if it works, everything goes well, return back to the result to the calling function, and then that's done. However, if it doesn't work, then the retry logic is in this circuit breaker itself, right? So it starts to retry. Maybe first it retries immediately again. What might have been a temporary network problem, but then it starts to do this kind of exponential backoff algorithm on the retries. So it'll retry every first 5 seconds break, and then 10 seconds, then 30 seconds, and so on. And then simultaneously, after some amount of retries, it blows the circuit breaker. That means that if another function tries to call the external microservice, this circuit breaker will immediately reply to the function that it's not working. So that way, we're not creating a huge amount of connections that we're trying to do to put to the microservice, and then possibly have our client waiting, but rather we can exit immediately. Say it's not currently working, and then the calling function, of course, needs to do its error handling based on whatever it does. And now this circuit breaker keeps retrying, right? And then once the service is back up, then it will close the circuit breaker to make it available again for the calling functions, right? So we're kind of making sure that not all of the functions themselves need to handle retries. And then we're making sure that, if one use case has figured that the third-party microservice is down, then everybody gets the benefit of that. Not everybody needs to go and try to connect to it if we already know from one hand that it's down, and then simultaneously the other way around. So once we know that it's back up, then we can let everybody know everything is cool, good to go. And what do we do with this? It kind of depends on whether you're in a synchronous or asynchronous flow. So in the synchronous flow, it's of course good that we get that reply immediately, that some dependency is down, and then our calling function can do whatever it can. Maybe tell the user, sorry, this function is not currently available. Please try again later, something like that. And then if it's asynchronous, then the calling party will use queuing or something like that to still handle the requests once the dependent service is back up again, right? So that, we're just queuing those messages, and then maybe letting some management level know that there's a big queue now, so something is wrong somewhere. Yeah, that's just kind of one example of what we need to do in addition to writing our normal code to be able to work in a microservices architecture.
So let's talk about the problems. For example, since we were talking about network communication, then latency is one of the kind of a drawback what you get if you move to microservices. So I'll give you an example. Let's say you have a monolithic application, which is a complex one, and it has internal components or modules or whatever you want to call them, and they are making thousands of kind of internal requests per second.
Mhm.
And now if you externalize those or split this into microservices, then you would be making thousands of extra requests or tens of thousands of extra requests per second over the network.
Yep.
That's one challenge, right?
Yeah. So latency will get added. The more
And
complex
overall network utilization, because
Yeah.
it's that
In the
could
cloud,
also become a problem eventually.
in the cloud, that normally is not really a problem, but yeah, in principle. But yeah, so the
If you have an
latency
EC2 instance at some point, it as a target, maybe not as a target from. But yeah, okay, then
right? No, but you're right. So
Yeah.
latency will be added. Now, one of the tricks that we can do, if we have this kind of a dependency graph, right? So on the top of the graph, we have the original request from the client, and then that kind of gets distributed, like a little bit like a tree, to all of the dependencies. So we can, of course, the first thing that we can do is we can decide which of these do need to be synchronous, right? So then with any asynchronous ones, we don't care that much about the latency. We just do not let them affect the latency of the request. So we are pruning the tree, taking away any of the nodes or subtrees that can be handled in an asynchronous way. Then we're still left with the synchronous one. And now this is depending on the depth, right? So the deeper that tree is, the more latency we get, because the more levels of requests we have. So another thing that we can do then is try to take some of that depth and move it to be shallower, right? So instead of calling one microservice that then does something to your request and then calls another microservice with that, maybe you can parallelize that. You can actually call both of those microservices from the first level already. And that way, even though the network connections amounts stays the same, the latency, the depth,
they happen at the same time. So yeah,
exactly. So we're kind of getting a little bit.
And sometimes, and maybe sometimes, if you have an extreme amount of messages flying towards some component, then maybe you just have to accept that, okay, microservice might not be the solution with that.
Yeah, kind of in general, if you have huge amounts of messages going to a specific target, then microservices might exactly be the solution for that.
I mean, like if it's a small component and if it's an internal component instead of an external component, then the internal component could be, if you take the microservice approach to the extreme and you're just externalize or
let's say that
everything as a microservice, then maybe you have gone too far.
Exactly. So
probably is
that
there is
we
probably
have a microservice
called
the calculator. So instead of calculating, summing two numbers in your code, you would call a microservice to do that on your behalf, right? That's kind of an extreme example, but I think that's what you mean, right?
Yeah, exactly.
Not everything is supposed to be done in a microservice. You need to do things locally as well. And that's an interesting topic that goes towards the design of microservices and microservices boundaries. So what is the proper size of a microservice? Depends, right? So one way to get there is this kind of domain-based design, where you try to take the business aspect of whatever it is that you're doing, the business logic, and then contextify things into different domains, and then make those be the microservices that are talking to each other. And there is some science behind this. There's some kind of key things here, like is the data local to that domain, or does it need to be transferred? If there's lots of data transfer happening, then maybe it's actually the same domain, so you shouldn't be using separate microservices for implementations and that kind of stuff. But it is a skill or an art in itself, just designing the
experience.
Yeah. And
okay, another one. Before we go too deep into the details of that, how about scalability? Why do microservices scale so well?
Well, the main thing here is that you can separately scale the microservices, right? So
instead of everything as a single unit, you take one and scale that.
Yeah, like let's say something stupid, like you have a monolith, and for whatever reason your logging functionality uses up a lot of CPU.
Mm-hmm.
And now you need to scale the whole application, the whole EC2 instance that you're running on, whatever, just because of that logging component. And let's say that you don't even use it. It only does something every hour, something stupid like that, right? Whereas in a microservice, you could separately just scale that one component instead of having to scale everything else as well. Then the other point is the speed of scaling, right? So the individual artifact of the microservice are much smaller, so they're a lot quicker to download. Let's say that you're running a container cluster, or microservices are containers. Whenever you scale, it literally takes like 1 or 2 seconds for the container agent on your instance to go and fetch that image from your container registry, compared to getting a whole big application, even if it's containerized. As soon as it is several hundred megabytes, it already starts to take some time to download and use disk space. So code size matters, right? So
definitely. There's something else regarding that as well. The scalability. I was going to ask you something, but you kept on talking, so
I got you distracted.
yeah. I should not have listened to you. Well, scalability is one thing. Smaller code, definitely.
Yeah.
Oh, yeah. Technology stacks.
Yeah.
You can have separate, like each microservice could be built using a different stack, technology stack. I'm against that slightly. Not, we'll come back to that. But you could, if you have a specific microservice that needs to scale in and out a lot, and it needs to do it very rapidly, maybe you choose the technology stack that is actually the one that is the quickest to start.
Yeah, exactly.
I don't know.
Yeah,
you could do that. You like really optimize something.
Not .NET or Java.
Yeah, definitely. Except for Java, there was this new
the
quick start. What was it called? Like very recent.
Snapshot.
Snapstart or something like that. Yeah. Not Snapchat.
No, so basically it takes a snapshot once the virtual machine, the Java virtual machine, has finished class loading. It takes a snapshot of the memory.
Yep. So there are ways to really optimize things, even from the technology point of view. But you probably know why I'm against of having complete freedom of implementing every single microservice just with whatever technology. Because that's basically, you can do it that way. But what's the challenge there?
Of course, you have the personal risk there, right? So, let's go through some extreme examples, and this has to do also with the idea of choosing your data store. So maybe that the data store is easier to understand and more handling, right? So each microservice controls their own persistence, so you can choose the data store for your persistence depending on what you actually need. So you don't need to put everything into a relational database if that's not optimal for your microservice. And there are many use cases for this that are great. Something like using a Elastic search cluster for our open search cluster, I think I should say nowadays, for like text search functionality instead of a relational database. It's much better. So you can do that. Okay, there's still a risk there because maybe we don't have that many people who know that database in the company. right? So there's a similar risk to what you are saying.
Similar, yeah.
So let's say, okay, so let's say that we get some benefits from this freedom of stack. Okay, so let's say maybe there is some specific thing that we're doing in our microservice.
Let's give a concrete example of what the freedom means. You could have a project that was written with Java, another one which is written with Python, and I don't know, COBOL or something like that. And then you have 3 different databases in the background. That's still not too bad. But then you take into account that every Java project has a different framework for UI, for example, or persistence, and it gets really complex. And that's
exactly
the freedom what I was talking about.
Exactly. Yeah, me too. So
just to give you a concrete example.
Yeah, let's say that there is something that happens to be very simple to do in a certain language. Let's say that our current implementation is done in Java, and then we're having some performance issues. Well, not Java, Python, and we're having some performance issues. So that's why we need to rewrite the functionality in something like Rust. Let's say Rust. Why not? Right? So or Go. Yeah. So there could be a reason for this, right? So there's actually a real reason for us changing the framework. It could also be that if we're creating some new functionality, and we have created our small 2-bits team for writing that, though the people there just happen to love Clojure. They're much more efficient in writing their implementation in Clojure because they're so fanatic.
Yeah. Of course.
So there are reasons why you would do that. However, the risk then is that, if those people leave the company, then you have a microservice that is running on Clojure and you have nobody else.
Nobody can maintain that. And that's my biggest concern there. Or even if the people stay there, it's only one person who can actually maintain that. Or if it's just one-off project, even that one person, after a few years away from that whatever framework they were using, and the framework has actually been discontinued, then you're lost. And that's kind of what I want to avoid. I think, in my opinion, there should be from your organization maybe a set of kind of approved technologies that you can use, and then those are supported, and you educate the people who are coming in as new people to the organization. They get educated into those as well.
Yeah, so that's of course how it works. But if we're talking about the very mature DevOps organizations like Amazon and Netflix and so on, then they don't really run into that problem because they have so many engineers working for them that there is always somebody who can take over. And the kind of microservices maybe are also a little bit like small companies within the organization, right? So they're hiring more people into that team, or letting people go from that team to maybe join a different team, right?
But would that be an extreme example in that sense that most of the companies are slightly smaller than Netflix?
Yeah, it is. But what I'm always saying is that all of the benefits that come from DevOps and these things, they can only be really gotten by these large organizations. Like if you're a 10-person company, then you can take some of the ideas, but you cannot implement them in the way that they are written, right? Because you're too small. There's no
yeah, that's actually something that I don't want to go into the DevOps side now because we're talking about microservice, but that's actually something that we should always remember to emphasize that not every organization because of the background or because of the size, it's not feasible. You cannot take all the benefits. You might want to have all the benefits, but you cannot get all the benefits if you're a small organization.
Exactly. Yeah. And you can always think about the way I teach it is that the DevOps your list of things to do and what not to do is not like a state that you are in, that you decide, now we're going to be DevOps. No, but it is more like a direction, right? So when you make your choices on how you create your development environments and your organization, then try to go into that direction, with the target being maybe somewhere far that you can actually never reach. So it's just kind of the spirit, being the spirit, even if you can't literally do everything the way that they're saying. But yeah, so one thing that is problematic that you didn't bring up yet to talk about.
Give me a hint.
Discoverability.
Yeah.
So if you have lots of services, you need to have some kind of methodology in place, basically a phone book for the services to figure out what is available and how to connect to them. Also, of course, the API description would help a lot in here. So then for that, things that have come up lately is service meshes. So service meshes externalize, again, the communication between microservices to proxies, and then the proxies get centrally configured by some control layer. So that way the individual applications don't need to know how to find some specific service, but rather it's the proxy part, which is common for.
But the service needs to know that they need something from.
Yeah, like I need a, let's say from the user service, I need to get the email address of this user, right? So I need to know that there is a user service available somewhere, and it has some functionality regarding getting that user, but I don't need to know the URL to be able to get there, right? So service meshes also allow you to do direct microservice to microservice communication, whereas the other option usually is to use an API gateway. So with API gateway, one of the problems is that we get these HTTP requests, and the handling of those takes time. So if you're in trouble with latencies, one of the options would be to use a service mesh.
How much faster is that?
You're missing one middleman, right? So the microservice talks directly to the other microservice. So it's
then definitely that's.
And then you can also use a different protocol. You can use something like gRPC, which is the Google binary remote procedure protocol. So that then again speeds things up slightly.
How about then when you're trying to figure out why things don't work? Those binary protocols are fun to debug compared to plain text HTTP requests.
Yeah,
that's like one thing I've learned over the years, that sometimes if you're willing to make things a little bit more slow and human readable, then of course it's slightly slower for the machines, but it's so much easier for the person to actually take a look what's going on.
Yeah, and again, you don't need to do a hard choice here, right? So anything that where you can handle the latency, of course, keep it in HTTP. But then if you have something like, I don't know, maybe some real-time IoT system, then it starts to make more sense to go towards the binary protocols. Yeah, so
and add some caching layer in between as well.
Yeah. So we're getting towards the end of the episode. We will be going deeper into some specific details on how to handle certain amounts of certain things in microservices architectures, like, for example, a transaction rollback in a distributed system, what kind of options there are, and then also some other best practices, like, for example, CQRS. So we will be talking about those later on. If you're interested in this talk in the topic, then the Wikipedia microservices page is actually fairly good, fairly balanced, and then it also has some examples of these different kinds of platforms that could be used. So we're looking at here Spring Cloud, as well as the Netflix OSS framework, and then, for example, Kubernetes as an option. So how these would differ in their implementation of different kinds of concerns that we would have from microservices. So that might be helpful in you trying to figure out how to actually implement microservices yourselves. But yeah, also there is microservices.io. This is I mainly use it as basically a pattern repository. So it has a pretty good explanation of most of the patterns that are being used in microservices. So you have, for example, the Saga pattern here, which is often referred to, the circuit breaker pattern, how to decompose a monolith into microservices. You have this kind of strangling pattern available in there, and so on and so on. So some of these we might be able to talk about in a future show. But yeah, just to let you know that this exists, and there are many smart people who have been smarter than me who have been working with this stuff. And yeah, just remember that the microservices is not always the correct option to choose. So there is this blog post that I should be publishing soon, where I talk about that myself. So it's still unpublished, but we will get there. We're trying to talk about microservices not being the way to go. And what was interesting here was that basically Sam Newman, one of the biggest microservices gurus, he's literally the guy who wrote the book on microservices. He actually does not tell you to use microservices. He tells you to create a single-threaded monolithic application first, and then only once you can't manage your application anymore, then to consider microservices. Another thing we didn't have time to talk about is this idea of figuring out when to move to microservices, this kind of crossover point. Maybe we're going to have a separate episode where we'll discuss more of that. There's plenty of topics within this context that we can chat about.
Yeah, and regarding that, early optimization, usually not a good thing, but sometimes you do know that, hey, this system that I'm building is going to be very heavily used. And I think optimization from day one is the key, because you're saving in some cases, but because I've seen it, that there's kind of stupid to make, if I use that monolithic application point of view, it's kind of stupid to build a monolithic application just because you can, and then transform it into microservice later on, if you know from day one that you're going to have millions of users accessing the same system per hour. And then
it's like technical debt, right?
Yep.
So you choose to do things in a certain way, knowing that you're going to need to change it later, right?
And probably a good thing here is if it's a conscious decision, that an educated guess that, okay, we should do it either A or B, and not just picking one in random. If you don't have that discussion with yourself or someone else beforehand, then the chances are that you make
so any technical debt that you take is, of course, a conscious decision. It's like when you take any other debt.
All right. I think we're running out of time.
Yeah, you don't go to the bank to just get money, rather you have some kind of a plan in place.
Hopefully.
All right. Thanks a lot for thanks a lot, Mikko, for again challenging me here. Always appreciated.
My pleasure.
And then
especially on this topic.
Yeah, thanks to all of the viewers as well. In case you have any topics that you think that we should handle, please feel free to send us comments. If there's something in this show that you want to comment on, that's totally welcome as well. Hopefully we'll see you again next Saturday at 12 o'clock Western European time, 1 o'clock CET, and 2 o'clock back where Mikko lives. Till then, thanks a lot.
Thank you. Bye-bye.